Welcome to Old Iron Machine Works. Let me start out by thanking my daughter Adelie. She got stuck on a bridge coming home from work. Uh, so she figured while she was sitting there waiting, she might as well do a little filming of the ship for her dad. So thank you, Adelie. This video will also be me rebuilding. I believe there's 3 different water pumps, but they're all F-1197 water pumps that I will be working on. So I hope you enjoy the video. On this first video, you can see the rubber totally eaten up. And these are kind of like a bellow style of seal. If you get a tear or any hole at all in that rubber there, it will leak fluid. So clearly you can see that one is totally shot. And on this one here, lack of grease. You can see the bearing flopping around in there. When that happens, that whole end piece needs to be machined, sleeved, in order to get the bearing to fit tight. Here you can see the amount of the wear a little bit better. That area right there is where it's completely wore out, and all that should be the exact same OD, or excuse me, should I say ID of that little lip on the outside. And this part's where the seal goes in. That actually cleans up, and that's pretty good shape, so that won't have to be machined on this one. So other than the end piece getting bored and sleeved for the bearing, everything else actually cleaned up nice on this pump. I should probably point out too, these are natural gas pumps on some old Waukesha engines, and unlike a lot of different common water pumps, you know, it's not like your car water pump. If it goes out, you throw it away and go buy a new one. You pretty much have to, if you can find good cores, is great, but I normally have to work with the best cores I have and machine them and try to patch them together and get as much life out of them as we can. And I do have a selection of spare engines and parts in the boneyard, which comes in handy. I tried to make the bushing sleeve as thick as I can, so I take it right to the edge of the threads of those 3 capped 1/4-inch holes. And here you can see I'm about as close as you can get, you know, without getting into the threads. Okay, here I got the sleeve pressed in. I just put some Loctite on it, press it in, and now it's just ready to put the bearing in and paint it, and it's ready to go out. That's the area right there that got sleeved. And once again, this pump here is pretty well done. Little paint and ready to go on the shelf. Here I thought I'd take you guys out and kind of show you what the 1197 looks like. This is an aerial reciprocating compressor. Those are the valve caps. I'll do some videos of valve repairs later. And here's a Waukesha 1197. And I'll kind of show right there. There's the water pump, bolted right to the front of the engine. And then you can see the cover on the front. They had options where you could run a pulley on the front also. Here's another one just on a core engine. And there you can see the cover. You can also put a pulley on the front if you needed to. We don't never need that. And then on the back of the water pump, most of the time we drive some type of ignition. This is an old obsolete ignition system there. But anyway, the back of the pump normally will just run the ignition system. And this brings us to another worn out water pump. Okay, I slowed down this clip so you could see the outer part of the bearing, which is still in place. And due to me Loctiting the bearing in, it saved the housing from needing to be machined. Generally what happens when the bearing locks up and goes out, it'll want to spin the bearing and destroy the housing. And yes, I am a huge fan of Loctite. It can save a lot of time and money. This pump was pretty much a straightforward repair. Nothing needed to be bored or sleeved. Just a basic water pump kit, and it's ready to go. Okay, here's a previous repair where I bored and sleeved it. They probably last a few years. If somebody asks how long will they run, they do run 24/7. The 625 is what I shoot for. Excuse me, 623 to 625, anything around there, and the seal will press in just fine. That kind of shows the fit, so a little sealer on there and drive it in and no problem. What happens over time is with corrosion and stuff, the seals just drop right in. And I've seen a lot of people, which I'm guilty. I've even tried to epoxy different ones in. Take the shortcut, try to eliminate the boring and sleeving. But now I don't mess around. I just, if it doesn't fit, nice where I like the fit, it'll get bored and sleeved automatically. Here, this will be the area that the bushing will drive up tight against. And yes, this is nothing more than just an end mill. I love working with brass. It doesn't take any high-tech stuff. the machine brass, and end mills actually work pretty decent. And here I'll show you one of my tricks using a drumstick to catch the... Okay, maybe I'll show you next time. Little area right there, I'm gonna go back into the lathe with it and just make a really nice small skim cut just to clean it up. I should also point out on these particular water pumps, you have two complete set of mechanical seals on both sides of the impeller. Of course, this is for one side of the impeller, and here you have the ceramic portion of it that pushes right into the impeller itself on both sides. And then on these sails, like I mentioned before, it's like a little billows style. So that rubber around the outside, if it gets any kind of little hole or anything in it, it will leak. And here on this machined pump shaft, they're mass produced, and when they come in, they have sharp edges. And if you're not careful, when you're pressing it through the impellers, it can actually shave off a little material, and then you lose your press fit. And here I'm over on the horizontal press. It does a great job of keeping the shaft nice and straight as I shove it through the new bearing. And here we have the impeller pressed on the shaft, and you can see the ceramic portion of it is pressed into the impeller. And on the top, what it has is it has an O-ring that seals from the ceramic portion of the seal to the impeller. And in here I got the other half of the mechanical seal pressed into the cover. And here we have another complete water pump. But wait, there's more. Okay, I'm sure you guys are probably tired of seeing 1197 water pumps by now. But here's one that I built a few years ago. Got a nice grease fitting in there, and the operators that have been taking care of this particular unit apparently did not know that they could grease the back bearing. And you can pretty much see that's the grease that I put in it when I built it years ago. And it pretty much wiped out that back bearing. But once again, the bearing was Loctited in, so it did not hurt the housing at all. It does need some other boring on this particular pump, but the back housing was fine. And what you can see here, this is a really early style water pump to where it used a different style seal. It was a much larger diameter seal, and then what they would do, that ring there, you would glue that ring in, and then you would press in the new style mechanical seal. And that's just some old sealer that I've tried in the past. It's actually epoxy and epoxied it in. And I guess you could say it kind of works, but I quit doing that. Now I just go right to machining and sleeving. You can see where I've already started machining it, and you could just see the corrosion rust pits. And I just keep machining it until I get a nice clean surface. And I want to have enough body thickness to the sleeve that it'll stay in. And there I got a nice surface for the sleeve. Okay, here I'm ready to press the bushing in, or sleeve. You'll see me call it bushing or sleeve. But whenever you're at the press, uh, sometimes just giving a minute to think about, where the pressures are being applied to. I've seen more stuff cracked and broke and messed up from, people just getting in a press and getting after it. Where here I have it, I have that slug right underneath, supporting right where all the forces are being applied. So there's pretty much minimal risk of cracking anything. Now this sleeve will end up getting machined again with a step in it. And back in the day, I would machine the step in it before I pressed it in. But being that the thing just clamps right up in the big 3-jaw chuck, now I just press the sleeve in, go back into the chuck after I measure it, and then machine the step. Okay, this is one of the newer style housings that uses the later style seal, and that's where I'll be getting a measurement off of. And then I'll transfer it over to the style here that I've already bored and sleeved, and get my measurement how deep I need to machine the sleeve for the step. Now you can see the spring on the inside of that seal, and you want to try to have your measurements as close as possible, because there's so much spring pressure of that seal that goes up against the ceramic, and you don't want to be too tight or too loose with it. Okay, this shows the seal better than the other ones. Where I said before, any kind of pinhole or crack in that rubber, and it will leak. And here I'm just gonna put a little sealer on it and drive her in the housing. This is another one of my favorite products. It's I get it from Sunnin, and what it is a interference fit lubrication. Anytime you have something fairly tight, like a shaft, press it into an impeller. It helps prevent it from galling. I love the stuff. Works awesome. Here I'm just applying it on the impeller side, to where the shaft slides in, it will not transfer the lube to the ceramic seal. It'll be pushing it the other way. Okay, here I'm pressing the impeller on, and I want to get the impeller centered between both housings. So what I'll do is I'll leave the ceramic part out of that end of the impeller, and then I'll put the gasket on, and then just set the cover on there, and then I'll just do a visual, just basically look inside and center up the impeller. I guess I've done enough of them. I don't need to measure them inside. I just get a good visual. Well, if you've made it this far into the video, there should be some kind of an award. Um, some people may find some of this stuff interesting. It's just part of my day job. I do work on an awful lot of different stuff, and I enjoy it. I've been doing it for a long time, and I still get satisfaction out of bringing stuff back to life and running a few more years. Anyway, once again, I appreciate you guys taking the time to watch the videos. If you like it, give a thumbs up. If you're not a subscriber, hit the subscribe button. And we'll see you on the next video.